Okay, students, I'm hearing that some of you are having a hard time accessing the link for today's assignment, Learning Goal 14, Activity 5, Light Spectrum and Wavelength. You can see here I'm on the forum. You click on the link, but the link's not working for you. When you click on that link, it takes you to this. It's called the electromagnetic spectrum. There's a green arrow here. You can see the wavelength and frequency and the amount of energy the waves have as you move it along. So right now we're on radio waves. And on radio waves, the wavelength and frequency here, it has a long wavelength, okay, a low frequency, and it has low energy. As we move it up, okay, we're still in the radio wave, but the wavelengths are a little shorter, but they're still long, and it has fairly low energy. And as we slowly move it up, here's microwaves. Okay, with microwaves, the wavelengths are, well, in comparison, they're still pretty long. The energy's still pretty low. Okay, and it talks about how microwave radiation is used to cook food by heating up the water molecules in the food and detect sea ice with satellites. Okay, if we move the green arrow up to infrared, okay, infrared would be more of a medium length wavelength. Okay, it has a medium energy. Infrared radiation is used in some television controls, night vision, photography, and sea surface temp imaging. Okay, we move it up to the visible light. This is the stuff we can see. Okay, visible light has a medium wavelength. It has medium amount of energy, and you can see the colors that we can see based on those visible light. Now if we move it up into the ultraviolet range, now we're starting to get, it may still count as medium, but we're starting to get into the high energy and shorter wavelength. Okay, ultraviolet radiation that seeps through the atmosphere is known to cause skin cancer. Frogs are sensitive to UV, so they are monitored to see the presence of holes in the ozone. Dentists use UV. Okay, so moving along, let's go up to X-ray. You can see the X-rays are quite short wavelength. They're high energy. X-ray radiation is used in dental X-rays, CT scans, and supernova detection. Okay, and then as we move all the way up the other end of the spectrum, we have gamma rays here. Gamma rays are very short wavelength. They are very high energy. And gamma radiation is the most dangerous of the EM radiations. It is used in nuclear medicine and the gamma ray background. Okay, so that video should give you an idea of what's required here, or what this simulation shows you, so you can fill out that table.